Greetings everyone, welcome back to my YouTube channel. Today I would like us to look at proof by mathematical induction. And to prove by induction, there are three key steps. To induce, you prove that it is true. Let's say you have to prove that a statement is true for all positive numbers. You start by proving that it is true for 1, n is equal to 1. Then you assume that it is true for any arbitrary number k belonging to that set of natural numbers. Finally, you prove that it is true for any sequence. Let us following by induction. If you have this is the sum from 1 to n r squared equal to n over 6 into 2n plus 1 into n plus 1. I should prove this for all n. Prove by mathematical induction. N belongs to a set of natural numbers. Okay, so for us to do that by induction, we start by proving that it is true for n is equal to 1. Or we let Sn be that statement. That all of that statement is Sn, or all of that statement is Pn. So true, let's verify whether it's true for n is equal to 1. When n is equal to 1, it means we are summing. Left hand side is from r equal to 1 to 1. This symbol means summation of r squared. So when r is 1, I'll put here be 1 square, which is 1. Now when n is equal to 1, the right hand side is substituted here. We are going to have 1 over 6 bracket 2 into 1. That's 2 times 1 since n is 1. 2 plus 1, 3 into 1 plus 1, which is 2. So 3 times 2, 6. 6 divided by 6 gives you 1. Hence, it is true for n is equal to 1. That is P1. Okay, now, being true for P1, we have to proceed now. We assume that it is true. The next step is we assume true for n is equal to k. If we assume that it is true for n is equal to k, what does that mean? That is, we are saying that the sum for r is equal to 1 to k of r squared is equal to k over 6 into 2k plus 1 into k plus 1. Now we are required to prove that it is true for n is equal to k plus 1. That is, we should have an answer of the form r is equal to 1 to n r squared. K plus 1 means n is equal to k plus 1 over 6 into 2 into k plus 1 is 2k plus 2 plus that one, 3. Then k plus 2. That is the result that we are required to prove. Now, since we are required to prove that, we make sure we use it well. So, make sure we use the proof well. Now, our assumption. Whenever they say assume that it is true for n is equal to k, it means that's what you are going to use. That's what you are going to use. R is equal to 1 here to k plus 1 when n is equal to k plus. We are summing from r is equal to 1 to k plus 1 with specific k plus 1. Okay. Now, having that in mind, we have our series here. If we are working on that, we have summation 1 to k plus 1 of r squared. What is it equal to? When you are summing from 1 to k plus 1, it's the same as summing from 1 to k of r squared plus, if you are to add things from 1 to k plus 1, right? It's like adding from 1 to k. The next term after k is k plus 1. Okay. If I'm to add from numbers from 1 to 7, I add from 1 to 6. The next after 6 is 7. Here is the k plus 1 term. Now, but what is our summation? This summation, this is it here. It is our assumption that we had. So k over 6 into 2k plus 1 into k plus 1. K plus 1 term means wherever you see r, you put k plus 1. K plus 1. So if there was r into r plus 1, you put k plus 1 there. You have here k plus 1, all that squared. Now you continue to factorize. There is 6 here. There is no 6 here. If I want to make the LCM here, I will have 6. Okay. And equally, there is k plus 1 here and k plus 1 square. So I have k plus 1. I'll factor it out. 6 divided by 6 is 1. 1 times k. So we have k into 2k plus 1 plus, here is 1. 6 divided by 1, 6. 6 times, it will now be k plus 1 because k plus 1 has been factorized. K plus 1. Okay. So we now have k plus 1 over 6. This one gives us 2k square plus k plus 6k plus 6, which will go ahead to factorize. I'm going to have k plus 1 over 6 into, we have here 2k square plus 7k plus 6. Okay. Now, which gives us this expression inside is a quadratic expression. When we factorize that quadratic expression inside, it gives us 2k plus 3, 2k plus 3 times k plus 2, which when you look at it, it is what we were proving. We wanted to prove this. We wanted to arrive that it is true for n is equal to k plus 1. We wanted to arrive here, and which gives us the required proof. So we'll conclude by saying that since it is true for n is equal to 1, n is equal to k, and n is equal to k plus 1, hence it is true for all n belonging to the set of natural numbers. Thank you. Stay tuned for more videos.